So, Dublin is racing towards a greener future. But a really fascinating new project there is forcing everyone to ask a pretty tough question. What's the real cost of clean energy? Today, we're digging into the hidden and, honestly, pretty surprising side effects of going green.
I mean, this is one of the biggest challenges we face, right? We all need to stay warm, but the planet desperately needs a break. So what's the solution?
To really get a sense of the stakes here, just look at this number, 36%. A massive 36% of all greenhouse gas emissions in the entire European Union come from just one thing: heating and cooling our buildings. That's a huge piece of the climate puzzle we absolutely have to solve.
To tackle this, Dublin is trying something pretty revolutionary. They plan on capturing the immense amount of waste heat that's just pouring out of a local data center and then using it to warm up nearby buildings. On the surface, it sounds like a perfect win-win.
But is it actually the best solution? Well, to find out, a detailed study compared 3 different ways to provide heat. So, let's meet the contenders.
So, first up is the old way, just upgrading the existing gas boilers to more efficient ones. Then you've got the high-tech way. That's our data center project, using a waste heat pump. And finally, there's the renewable way, a central plant that burns biomass, like wood chips, to generate heat and power.
Let's just zoom in on how that high-tech option works, because it's pretty clever. The system grabs the hot exhaust air from the data center, then it uses a heat pump to boost that temperature even higher, and finally sends that superheated water through pipes to local buildings. It's a really brilliant piece of energy recycling. Okay, so 3 systems. Which one is the greenest? It's time for the carbon face-off. Let's start with the most obvious question. Which one produces the least amount of carbon?
Well, the first round of results seems pretty clear. When you look at global warming potential, this bar chart shows that both the heat pump and the biomass system are way cleaner than the old gas boiler. So far, no surprises.
And when we look at how much fossil fuel they use, it's pretty much the same story. The 2 new systems totally crush the gas boiler. And the biomass option, since it's burning wood chips, barely uses any fossil fuels at all. It's the clear winner here.
Okay, at this point, the decision seems pretty simple, doesn't it? Both of these new systems are a massive improvement. You'd think, case closed.
But what if I told you that looking only at what comes out of the chimney misses a huge, and I mean huge, part of the picture? This is where our whole investigation takes a sharp turn, and we uncover a hidden cost that changes absolutely everything. Take a look at this. This chart measures something called Human Toxicity Potential, which is basically the overall harm to human health. And in a complete reversal, our so-called green heroes are suddenly the villains. The biomass system is 5 times worse than the gas boiler, and the waste heat pump, it's a staggering 8 times worse. So what on earth is going on here? Well, the answer lies in a concept called a life cycle assessment. It doesn't just look at the fuel you burn, it looks at the entire environmental bill for a system, from mining the raw materials to building the infrastructure, all the way to its final disposal. And here's the crucial point. The toxicity isn't coming from the energy source itself. It's from the massive amount of stuff you need to build to use it. We're talking about new energy centers manufacturing kilometers of steel pipes, all the diesel-fueled construction work, and mining for those raw materials. The only reason the old gas boiler looks so good on toxicity is because all of its infrastructure is already in place. So now we have this really difficult trade-off. Less carbon, but more toxicity. But hold on, because the story has one final twist. Turns out, the best choice isn't static. It actually changes over time.
Remember, the waste heat pump runs on electricity from the national grid. So, on the left, you can see its carbon footprint using the Irish grid from back in 2016. But on the right, that's the projected footprint using the much cleaner, more renewable grid that's expected in 2030.
And the difference is dramatic. As the electricity that powers the pump gets greener, the pump's overall carbon footprint shrinks by an incredible 42%. All of a sudden, it's looking almost as low carbon as the biomass system. And this really brings us to the heart of the matter. How do we make the right choice when the goalposts themselves are constantly moving?
So, what did we learn from Dublin's heating dilemma? Well, a few big things. First, there is no single perfect green solution. Second, the hidden costs of building all this new infrastructure are real, and they can be massive. Third, the best choice today might not be the best choice tomorrow, because it all depends on bigger things like how green the national grid is. And ultimately, that all comes down to life cycle thinking. We have to look at the entire system from cradle to grave.
In the end, this Dublin study teaches us that the greenest path forward isn't always the most obvious one. It's not about finding some simple, magic bullet solution. It's about understanding the complex trade-offs, looking beyond the obvious, and choosing our path forward with our eyes wide open to all the costs, both the ones we can see and the ones we can't.